Okay, folks, this is the 2010 higher level, so that's 2010 higher level question C2. So we're going through all the structural forms there basically, okay? So again, I've set it up as far as I can before it starts getting a bit complicated. So the question is the woman's hat, and you basically just have a hyperbolic paraboloid that's being extended out into a ellipse. Okay, so we're going to be dividing our plan here of the hyperbolic paraboloid into equal elements. What do they do in the solution? Let's have a look. They have only 3 elements in the middle here, so we'll go with that. So we're going to divide this length up into 4. So let's have a look at the length here. 90 divided by 4 and actually work out. That actually works out for me as 90. So divide that by 4 is what? 45, 22 and a half. We'll go for it. You can divide it up mathematically if you, or graphically if you want, but I'm going to actually divide it up using let's see if I get a bit better light here. Okay, dividing up using my ruler. Okay, so 22 and a half here. My head is in the way, of course. 22 and a half. Okay, and then 45, and then what would that be? 67 and a half. Yeah, 65, 67 and a half there. Okay. And then these are just parallel, so you can use your sliding set squares, okay, to just divide up those elements. Okay, so that's going straight across like that. So it's a parallelogram, so it's much easier to divide up. I'm going to draw these pretty heavy, because Mark gave me a good tip there that on the video it was kind of hard to see some of the lines on one of the questions I did for the early level, so I'm just going to go a little bit heavier than I normally would, okay, with these lines. And yeah, so that's 1, 2, 3, 1, 2, 3, and again I'm going to say, actually, you know what, I can use my set square here. Okay, I'm just going to go across like that and just mark that there, there, and here, and from the other side here, and here, and here. Alright, and again, it doesn't really matter where I go with this, but I'll go 4, 5, 6, and 4, 5, 6. Okay, so by the way, I've actually already drawn the ellipse using my 60-30 method there to find my points. So, you know, 30-degree line, hit the major circle down, hit the minor circle out, and there you go. So you draw that as light as you can to get this ellipse here, and draw that as neat as you can, otherwise it'll make the drawing harder to figure out. Okay, and then elements 4, 5, and 6. Okay, actually I should be using sliding set squares here, just to make sure they're parallel. There, okay. Oh, messed that one up. Okay. Yeah, there anyway. Okay, and look, I'm just going to join in by hand, save time there. Now, that's the elements, that's the quadrilateral there of the, whatever you call this, diamond shape, okay, A, B, C, D being divided up into 4 elements. So they did only 4 elements there. 3 or 4 would be loads, as in 3 elements here, sorry, division of 4. Divided by 5 to get 4 elements, that's enough. Anything higher is going to start getting, the drawing's going to get way too complicated. So, how do we get that shape up here? If I could just, very quickly, we're looking for, doing the shakiness now, it's not an earthquake. I'm going to just very quickly point to the screen there. We're looking for that shape there. Okay, rough and ready, I know, but I don't really have a way of switching like I do in school. I was able to switch between stuff when I was projecting. I can't really do that here. So I'll just do it like that. Okay, so we're looking for that curved shape on the top here. So you get it by extending the elements out further. Okay, like that. 2, 2. So you extend them out onto the ellipse. So that's why you have to draw the ellipse first. There. I'll do the same thing here. Okay. And 6 is there. Okay, so you need to draw 6, yeah, so they extend out here, so you can rename if you want here. 6, 5, 2, 3, 4, 5, and 6. Okay, oops, 1, 2, and 3 over here. Whoop, pin broke. 3. Okay, right. First thing to do anyway, I would do is bring your elements from the parallelogram here, okay, the quadrant, the diamond shape, up to itself on the plan first, on the elevation, sorry, first. So there, from the plan here projecting up, and I'm only just going to go, actually again I'm making a mistake, I should only be going from the top here to reduce the amount of lines I'm drawing on my page. So there are my points. So this is 1, 4, this is 2, 5, I got 6. This is 3, 6, this is 4, 1, this is 5, 2, and this is 6, 3. And again, I'm 6, 3s because when you're looking up this way, from this direction, you'll see 6 first, and then you'll see 3. When you're standing here looking that way, 6 is in front, 3 is behind, so you put them in order of the way you'd see them, from front to back. It doesn't make a huge difference in this question, but it could in other questions, okay? So now, here's my elements joining across like that, but I'm actually going to extend it beyond like that, okay? And this is 2 and 5. It's actually a horizontal line. Okay, so that will be a horizontal line. I'm going to go horizontal here. Make it cleaner. Okay, and I'm extending them out beyond actually the points there, okay? And then 6 and 3, 3, 6, they're the same elements, okay? So I'm going to come along here and extend them out. Okay, so how now? So there's actually, the shape is quite simple there. Okay, we can draw our inner curve here, but the outer curve is the problem here. And it says on question 1, for part 1, ignore the hole here in the elevation. So they literally want you to draw the full curve here and then figure out the hole after that. Okay, so well, I can go ahead and draw that now. So I go from B, and I just go tangential to these. Tangent, tangent. Oh, broke my pen again. That's what you get from buying it from Tesco. No. And there. So that's our parabolic curve there going across like that. Okay. Now we get the outside curve. So basically element 1 down here, right, will extend out beyond, okay? Will extend out beyond and hit the ellipse, and then you have the same element in the elevation. So you basically find where it hit the ellipse, and 4 is the same, and you bring it out, and that's it there. Okay, 2 and 5, exact same thing. Wherever it hit the ellipse, the element gets extended out. Wherever it hit the ellipse, I'm going to bring that up to hit there. Okay, so that's 1, 4 as well, and this is 2, 5. The extension of it, we could give them new numbers maybe if you want to, make it easier to understand. I don't know. Look, I'm going to stick with this now, and that's 3, 6. So that then is the curve. I shouldn't have extended that out so far. Now that looks a bit messy. Rub him out. Okay, 8 minutes, good stuff. I'm going to try and keep it at 15 minutes because it takes me an age to upload these. So that curve just goes down like that, and you just have to do the same thing on the other side. So 6 extends up to 6, and 3 is the same thing. 3, 6, 3, so it's the same line. It is all symmetrical basically and kind of overlapping. Oh, yeah. 5 and 2 are in line with each other. If your ellipse is drawn correctly, they should be in line with each other. So I bring them up. Okay, and 4 and 1 as well. And here. So that's the new points there. Okay. Okay, what I might do is make this video public, because I think if you watch this on the DCG website, you can't use the slow controls and full screen and stuff like that. But if I make it public, you can hop over to YouTube and watch it in slower speeds if you want. If I'm going too fast, you can actually physically slow it down. I'll sound like I'm drunk, but at least you'll be able to follow it maybe a bit better if I'm pointing out things too quickly or something like that. Also, you can just pause it a lot. That's how I learned songs and stuff like that on YouTube years ago. I just pause the hell out of everything. So now we have to figure out the hole here. Okay, part B of the question is figure out how this hole looks. So the cutout will form its own little curve inside here. Okay, you can look at the question to see that. Okay, I'm not going to be hopping the camera over and back. So this curve would want to be fairly smooth. Well, actually, it won't make a difference. But you would want to make it fairly smooth for the actual marks of the question. But for the part 2, it doesn't actually matter. So we're the outsides of the hole anyway. Here, okay. So that's where it's going to start. There, and this is where it's going to end. Okay, so we've got a curve that's going to start here and end, go along here and end here. Okay, so how do we find the actual points on the curve? Well, it's obviously where the elements that we used already are cutting through the hole. So it's the same thing as being extending it out, it's being cut in here. So I'll just find this point here. So this is where it cuts 2, alright, and also 5. So I bring that up, that's it on the 5, 2 line. So they're all on the same line where it extends out, where that is on the hyperbolic, the quadrilateral, and in here. So that's that line there, and where it cuts 1 and 4 here. Okay, so I bring that straight up. There's 1 and 4. And same on the other side. It's 3 and 6. Okay, so 3 and 6 is here, and then I just bring that up there, and then I also bring up. I'm getting a bit lost myself here now. 2 and 5. Okay. Okay, so there's our points on the curve there. Now, how to get the lowest point? How do I do it in the solution? Oh, yeah, they just took they just created a new element parallel to this. So what I'm going to do is I'm going to take this element. Okay, sorry, I'm going to take, say, the element 4, and sorry, there's a bit of a shadow there now. Okay, might have to change the way I'm facing for the drawing or something like that, out the window or something. I'll figure it out. There's the element 4, and I'm just going to go parallel through the center here, so the bottom of the thing. Sorry, take my hand out of the way there. Through the center of this. Okay, it's the base of that. If I create a new little small element up here, and I just go up beside a 4 here, okay, and I go up beside 4 on the other side here, oops, there, okay, and I join them to each other, okay, join them, I have to leave them a small bit. They'll cut through the bottom there. So if I just call this thing, I don't know, S, okay, S, and S, I find S here. I also find S up here, so it's to the left of 4, so there it is, there's 1, 4, there's the left of 4, there's S. So I join S to S, and that cuts through the bottom, and it gives me the very bottom of the curve. You could probably draw it without it. But I'd say they're looking for that, you know, that kind of level of accuracy, or you know, the ingenuity to find an extra point like that. Okay, now, yeah, so you could leave that curve there to ask you to draw that in the part 1. Okay. And that's that part, okay, and that's that finished up until part C. Part C is a plane director for the elements AD and BC's position so that it contains a point B. Draw the traces for this plane director. So same thing, AD and BC, okay, our AD is there and BC is there. A plane director for the elements AD and BC, okay. So again, we are just going to figure this one out. Okay, so if you look at BC there, okay, it's a line on the elevation. I'm going to heavy it in a bit. Okay, it's a line that goes directly to the plan there, okay, or directly to the ground, I should say, and there's AD. Okay, just heavy them in a bit more. Okay, so BC, so C, okay, is on the C is on the ground, okay. Therefore, what did I ask for? Oh yeah, plane that goes through the line A, B, C, D, okay. Line goes through BC and through B. Plane director for the plane that goes through B. Okay, draw the traces for this plane director. Okay, so BC there. Okay, BC is an element. One leg of it is on the ground. Okay, and AD is parallel to it already, so we don't need to draw a view of it parallel to it. Okay, so what we can do there is basically say that BC is actually on a vertical plane there. Okay, so a plane that goes through BC. Okay, so if we extend BC, okay, this would be a line on the ground up to the XY line. Okay, and then we know it's on a the plane itself is vertical. Okay, so that's actually the trace, and this is a trace of it on the ground. Okay, I'm not explaining this very well, Okay, if you have any questions about it, let me know. Okay, but essentially C is already on the ground, so therefore if BC is on a plane, okay, if BC is on a vertical plane, okay, and C is already on the ground, then the horizontal trace HT will already contain C and B, okay, and then then that makes it a vertical line. So that makes our vertical trace just an actual vertical line on the plane, okay, and because BC or AB is parallel to DC as well, that creates that situation there. All right, we'll have to look at oblique planes and stuff like that, and vertical traces and stuff more fully down the line. Okay, but that's only a part C anyway. It's not a huge amount of marks, and it'll be more obvious in other questions how to actually figure that thing out. All right, that's the video. We're at 16 minutes. I'm going to stop that now. All right, thanks lads.